This next ToDoodle is one of the more important ones we do as far as getting you ready for the GED. Our warm-up was rearranging numbers, and our real-life issue is about how to sort word problems. And this kind of seems strange, perhaps, if no one has asked you to sort word problems before. But the hard part about word problems is turning them into the math stuff. And once you get it as a bunch of numbers and symbols, then that part you can do. What makes word problems extra tricky is figuring out, what are they wanting me to do? Am I adding? Am I subtracting? Am I multiplying? Am I dividing? Like that. So some people, I have to warn us, like pictures. So for the sake of those people, I have lots of pictures coming up. If the pictures help you, great. That's why I put them there. But if that's not how your brain works, that's fine. Ignore the pictures. Just like there was some stuff at the end of last class where if you didn't quite get it, it was not important at all. Then if the pictures don't help you, that's fine. And it's not your job to understand the pictures if they are not working for you. They are for other people. Okay, so all of our examples are going to focus on verbs, which is an important thing. When you are trying to figure out what is a word problem asking, then think about action. If you instead try and focus on adjectives, you'll get confused. Because English has too many adjectives that apply to more than one type of arithmetic. So, like total, an adjective modifying the noun amount. What kind of amount is it? It's the total amount. That might be because we added, or it might be because we multiplied. Or a leftover amount. Leftover might be because we subtracted something, or because we did some division. So think about the action, the verbs of what's happening. So here's all those pictures I warned you were coming up. Addition talks about combining. I had 4 things, and then we also attached 2 things, and now we have 6 things. And addition doesn't look like this. It's that we have this much money from one week and that much money from one week from another week, and it all goes into the bank account. Or we have this many apples and this many oranges, and how many pieces of fruit are there all together, or whatever. But it's combining. We're taking so many of this and so many of that, and then we're considering that they're all actually the same and counting how many we have. Everyone okay with my addition picture if they like pictures?
Yeah.
So subtraction has 2 pictures. It could be that we're removing things from what we had. We had 6 things, but we reach down with our hand and we take away 2 of them, and now there's 4 left. And if this is of subtraction, the way it's normally taught in elementary school, this is what you picture fraction as. It's removing from a pile. But subtraction also has a different picture. If I keep counting beyond some number, that's subtraction. If I have 4 things, how much more beyond 4 do I need to get to 6? That's also 6 minus 4 is 2. Does that make sense?
I think so.
So how many more past this number do I need to get here? That we wind up doing subtraction. It's a little different because the thing you're looking for is in the middle and it has a plus, but what you really do to solve it is 6 minus 4 is 2. Okay, multiplication, if it seems trickier, it's because there's 4 different pictures for multiplying. We could be making photocopies. I had 6 things, and then each of them, I make a copy in the background. And now when I count them, there's 12. So this is the kind of multiplication that you see most often in school. I get paid this much money each week. I work for 5 weeks. How much money do I have? Right? I'm making copies of something. So far, so good?
Yep.
multiplication is also shattering things. If I have 6 cookies and I give each kid at the playground half a cookie, how many kids get half a cookie? So 6 times 2 is 12, not because I somehow photocopied my cookies, but I broke them into pieces. Okay, here too?
Yeah.
The word of usually means multiplication, almost always, but not quite. I put the word of here a couple times just to let you know it isn't exactly that. So copying all of something, or saying I get half of this, how many halves are there? Right? There's some ofs in that language. Similarly, if I'm subtracting a fraction of something, that's multiplying. I have 6 things, but I only actually get half of them. So I set out 6 cookies on the counter. The ants got into half of them. How many cookies are still nice for me to eat? Half of 6 is 3. Are we okay with selecting a fraction of something being multiplying?
Yeah.
We'll see more actual math examples of these. For now, I'm just saying, if you like the pictures, does my picture language match your brain's picture language? And then similarly to fractions, it could be a percent. If I said half of something, let's write that as 50%, because 50% also means half, then yeah, half of 6, 50% of 6, it's the same picture. Division also has 4 pictures. We could clump things together. We can make equal-sized piles. So I have 6 things. I put it in 3 groups, or I put it in groups of size 2. Either way, it's clumping. I have 6 things. I put it in groups of size 2. How many groups do I have? I have 6 pieces of candy. I give each kid 2 pieces. How many kids get candy? 3 of them do. Everyone okay with that picture?
Yeah.
There is a shattering that's also division, which is kind of sad news because shattering was multiplication. But if I say I have 6 things and I break them into halves, then 6 divided by a half is 12. How many halves are there? There's 12 of the halves. So it's the same picture as before, but one way we're saying each piece is turning into 2 pieces. I have twice as many. And the next one, we're saying each piece is turning into a piece of size 1/2. But it winds up being the same thing. And this one you might have to stare at a little bit, kind of meditate on how those are the same picture, even though one is multiplying and the other is dividing. If I want to make a fraction, not that I start with a fraction and say half of something, but I want a fraction, then that's division. I have 2 things that are special out of 6. How many are special? 1 of the thirds. So there are 6 cupcakes. I get cupcakes. What fraction of the cupcakes do I get to eat? 1/3 of them. That's division. This one is easier to understand because in one case, the fraction is what you start with, and the other is what you end up with. And then this one is the same thing, but we're making not a fraction, but a percent. 33% is the same as 1/3, just in percent language. So if I have 2 cupcakes, there's really 6, but I have to share them, but I get 2. What percentage of the cupcakes are there? Do I get? I get 33%. Okay, that was a lot of me just narrating and pointing with my laser pointer. Questions about any of that page?
Not yet.
Not yet. Okay. So since I knew you would say that, let's see how well you really understand. If you are fortunate enough to have the kind of computer where you could look at my shared screen, which I need to keep sharing because we're recording, and also go back to page 4, so you have both at once, then that might help you. So your job now is to take your mouse instead of me doing stuff. And up top, we have things you can slide around with the arithmetic operations. So this is just a matching project. Make copies of the plus, minus, times, and divide as you need. And for each word problem, figure out which arithmetic operation is happening. And if it's not obvious, go back to the previous page and see which picture is happening. Remember to think about the verbs, the actions, right? Are we shattering? Are we copying? Are we combining? Are we removing? Yeah, that will help you. So I'm going to pause the recording for now and let you work on this, and then I'll resume the recording and ask you to sort of defend your answers for the people who are at home. So here's our answers. I want to talk about 3 of them in particular on the recording. So to prepare for a party, you make 10 vanilla and 10 chocolate cupcakes. How many total did you make? If I have 10 of this and 10 of that, then I'm combining those 2 piles of 10, I'm getting 20, so I'm adding. In the second one, I have 4 colors of frosting. Imagine in front of me on the counter in the kitchen, there's red, blue, green, and pink. And I put each of those on 4 cupcakes, 4 reds, 4 greens, like that. Which picture is that? I'm making copies. 4 reds, 4 greens, and so on. So that's multiplying. After the party, there's 6 cupcakes. I eat 2 of them. How many are left? I'm taking away. My hand is grabbing 2 cupcakes. And the ones I want to go over. After the party, there are 6 cupcakes left over, and I eat half of those. How many are left? So, whoops, that is here, this picture. There's 6 left over. I get to eat half of them, making me smile. What? How many are left? 3 are left. These 3 for somebody else. So that's multiplying. Half of 6, pretending that the multiply symbol means of. Half of 6. I'm starting with the fraction and using it. And that's multiplying. A very different thing is if I am making a fraction. After the party, there's 6 cupcakes left over. I eat 2. What fraction? I didn't have a fraction before. I'm making a fraction. What fraction of the leftovers did I eat? That's this picture. I have 2 out of 6. If I were to draw these as thirds, 1/3, 2/3, 3/3, one of these thirds is my third. So I eat 2 out of 6, and that makes the fraction 1/3. Making fractions is division. And then lastly, after the party, there's 6 cupcakes. If I eat half a cupcake as a snack, how many snacks will I get? How many days can I do that? If every afternoon I grab half a cupcake and exert my willpower and stop eating, then how many days do I do that? Maybe they're in the fridge so they don't go stale. So that's this picture of the 2 kinds of shattering. Then I am shattering into fractions. Each cupcake I'm slicing in 2. And if I only eat a half of a cupcake, then I can do that 12 times. Day 1, day 2, day 3, day 4, day 5, day 6, day 7, day 8, day 9, day 10, day 11, day 12. So why is this a good thing to do? Think about the action words. And if it helps you, think about the pictures. And it's easy to find word problems. You can go the top of any topic to look at the textbook sections. Let me make that bigger. And click on these and go to the textbook. You can look for word problems online. A great thing to do as you get closer to taking the GED is to go to places that have word problems and don't try to answer the word problems. Just try to sort them and then peek at the answer key and see if you sorted it right. Did you recognize that this one was addition, that this one was multiplication, that this one was subtraction, and so on? Because again, that's the trickiest part. Once you know that this one is 10 plus 10, then doing 10 plus 10 is pretty easy, especially since on the GED, you get your calculator for most of the test. So practice just identifying what type of arithmetic it's asking you to do. And don't worry about solving the word problem. And that's great practice. That's also something you could do this term. You could say, before my next class, I'm going to just open my book and say, let's go to multiplying. And I don't want the add. And find a word problem, blah, 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 blah. Here we go. Can I figure out what I'm doing? It's probably multiplying because I'm in the multiplying section. And yes, they're multiplying. I got it right. Do that a few times. And if you don't get it right, bring it to class. And next class, ask me, teacher, how come this one is division? That doesn't make sense to me. And we can talk about it together. Okay, moving on. This is the homework part. We're not going to take time tonight during class about this, but a great way to get better at something is to do it backwards. So can you write an addition word problem that uses combining? So maybe stare at this picture and say, 4 and 2 more. My son starts babysitting. 1 week he earns $45. The next week he earns $15. How much has he earned babysitting so far? There we go. That's my problem. And just go through all 9 of these verbs and try and make a word problem for each of them. We can either share them during class and challenge each other, and you can sit back and cackle maniacally as we all try and do your word problem. Or you can just share them with me and say, are these right? I really did them. Addition, subtraction, the ones I'm trying to do, and I can say, yes, good job. So that's a great thing to do over the weekend. Questions about that type of homework?
No, should be fun though.
Again, it's not your job to solve them. Is the answer 20? Is the answer 400? That's not your problem. That's whoever you give it to. That's their job. Okay, and the discussion, describe what strategies or habits you have already been taught about turning word problems into arithmetics. I mentioned of usually means multiply.
Thing he's reading.
So maybe you've learned that. There might be other things you've learned. What do you do to get word problems and turn them into numbers and symbols? What do you do that wasn't on this ToDoodle? Or how did this ToDoodle give you some new tools? I'm not going to record this part, but I do want to talk about it. So I'm going to end the recording.
No, I just got